to finish up this chapter on acid-base titrations, I want to talk about one of the most common uses of acid-base titrations. This has come up in class before, but just want to talk about it in a little bit more detail. And the largest use of acid-base titrations in the world is what's known as the Kjeldahl nitrogen analysis. Let me make sure I can spell this right. I believe it's a Dutch name, if I remember right. Okay, and this is used worldwide, probably on a daily basis, in the food industry. And this is a way to analyze the amount of nitrogen in organic substances. And specifically in food, we care about it because the three main components of food, right? If you go and look on your nutrition label, you'll actually see these listed, right? We have carbohydrates. So these are your sugars and starches. We have fat, and we have protein, right? Those are the three basic building blocks of any particular type of food. Now, if you think about the chemical structures of carbohydrates and fat, these only have carbon, hydrogen, and oxygen as part of them. Protein, on the other hand, because this is made up of amino acids, as we've looked at in this chapter, these are the only one that contains nitrogen. So if you can find the amount of nitrogen in a food sample, that gives you a proxy for the amount of protein, because protein is the only thing that has nitrogen in it. Now, of course, protein is completely composed of nitrogen, so you have to know a typical, how much nitrogen a typical protein has in it, and it depends probably on what type of protein you're looking at. But a typical protein has something like 16 weight percent. 16% by weight of nitrogen. So if you know how much nitrogen there is in your sample, you can then say, okay, well, that's 16% of the protein, and so you can back out how much protein you have. So this is a way to test and make sure you have the right amount of protein that you expect in your food. So this is why Kjeldahl nitrogen analysis is used worldwide in the food industry. And so how does this work? So we take our food, or organic matter of whatever type we're looking at, that contains carbon, hydrogen, nitrogen, oxygen as well, and you place it in boiling sulfuric acid. So that's going to convert all of your nitrogen will get converted into ammonia, NH4+. All of your carbon will react to form CO2, and all your hydrogen will form water. So if you notice, so one of these is a gas that's just going to leave as your food gets boiled. One's water, which is not an acid or a base, and so we only have one thing. We have all of our acid that's present, but all of our nitrogen gets converted into this NH4+ form. So we can keep track of it that way. And so they'll leave them. So the carbon and hydrogen will leave the mixture. We can basically we've isolated the NH4+. So then we take our flask that has our NH4+ in it, and we add base, and that's going to convert all of our NH4+ into NH3 and also neutralize the boiling sulfuric acid that we were doing all of this in. So now we have our nitrogen is all NH3, and then the next step is to distill the NH3 into a known amount of hydrochloric acid. So we know the concentration and we know the volume of the solution that we're distilling the NH3 into. So if we want to visualize this, right, our NH3 is being boiled and distilled into a badly drawn flask full of HCl that we know the amount of. Okay, and so the HCl is in excess, and so we back titrate the leftover HCl to figure out how much reacted with the NH3. And we'll back titrate that with sodium hydroxide, right? Some just very common, cheap, easy to get obtained strong base. All right, and so the total process of all this is we can figure out how much nitrogen was in our original sample by knowing how much ammonia reacted with the HCl. Okay, so that is one handy thing to know, right? It's a handy thing to know. So if we want to keep track of the reactions, right, we have NH4 plus is going to be generated, right? So this is from the food plus boiling sulfuric acid. And that's going to be neutralized by the base and form NH3. Then we distill that NH3 into a strong acid, turn it back into NH4, and then we back titrate the excess H plus will react with OH minus to form water. Okay, so that's the basic idea of the Kjeldahl nitrogen analysis. In the next video, we'll talk about one particular time where the use of this was compromised, and it's a sad story.